Hello, everybody. Mr. Webb here to teach you how to rationalize denominators. I actually brought in a special guest today to help me do that, Arnold Schwarzenegger from the Terminator. Hello, Mr. Webb. Thank you for having me. It's a pleasure to be here. Yeah, you're welcome, Arnold. Let's get started, shall we? So our goal is to rationalize denominators. The essential question is, how do you get rid of radicals in the denominator? I have no idea how to do that, but I'm the Terminator, so I will figure it out. That's good, Arnold. Thanks for having such a positive attitude. Yeah, you're welcome. Your students seem very lucky to have you, Mr. Webb. You seem like a really cool guy. Oh, thanks, Arnold. You too. All right, so one of the rules in math is you can't have a radical in the denominator. Why not? That's just one of those rules that somebody way smarter than me and you, Arnold, came up with. Hey, who you calling an idiot? Not saying you're an idiot. Easy, buddy. Just saying there's a lot smarter people than you and I out there. All right, so it's just a rule. And here is how we terminate it. Terminate it. I'm good at that. So in order to do this, we need to get rid of the radical in the bottom. All right. So I'm just going to show you an example of how I do that, and then I'll have you write down the steps on how to do it. All right, so we're just going to change how this value looks. 4 times the square root of 3. And the way we do that is we're going to look at that radical in the denominator there, and we're just going to multiply it by itself over itself, because that's just a fancy version of the number 1. Square root of 3 over square root of 3 is 1. So whenever we multiply a number by 1, we don't change the value. We're just going to change how it looks. All right, and multiplying fractions is easy. You just go right across the top. So we can go 4 times the square root of 3 on the top. Now remember, you can't multiply those together because one's under a square root and one's not. Okay, but on the bottom, square root of 3 times square root of 3, I can multiply those together because they're both under a square root. All right, and that's going to automatically give me a perfect square on the bottom since I multiplied a number by itself. And we know that the square root of 9 right there is just 3. So I can calculate that and I get 3. Now notice how I don't have a square root in the bottom anymore, and that is called rationalizing the denominator. That was pretty easy, Mr. Webb. I think you would make a good Terminator. Oh, yeah? Well, let me try out my Arnold Schwarzenegger voice, Arnold, and see what you think of that. Hasta la vista, baby. You're much better at mathematics. Why don't you stick to that? Okay. Sorry about that, Arnold. How do you say it, by the way? Hasta la vista, baby. Yep. Spoken from the man himself right there, Arnold Schwarzenegger. Okay, so in summary, what you need to write down, because you're going to do this in every single problem today, is you need to multiply the numerator and the denominator by the radical that's in the denominator. Okay, and we're going to go through 4 examples that look just like the ones in your homework, and you can refer to these to help you. Okay, and once you get the hang of it, this is actually pretty easy. So here we go. Rationalize the denominator here. Okay, there's an issue because I have square root of 5 in the denominator. So I am going to take care of that right now by multiplying this fraction by the square root of 5 over the square root of 5. And I picked the square root of 5 because that's what was in the denominator. All right. So on the top, I can't actually multiply 7 times 5 because one's under a square root and one's not. So I just leave it as 7 square root 5. And down here, I can multiply those together because they're both underneath a square root. So I get square root of 25. And we know that the square root of 25 is 5 because 25 is a perfect square. So that took care of rationalizing the denominator, and that gives me my final answer. Now, and if I plug this into my calculator, and if I plug this into my calculator, I'm going to get the exact same thing. It's just this is the accepted way to write it in mathematics. So you'll need to know how to do that when moving on to Algebra 2, college algebra, and anything like that. All right, so let's do another one here. Now notice how this one's a little different, and this one's gonna match number 2 on your homework. So if you're stuck on number 2, just watch this problem right here and get you right through it. Okay, so now notice there's 2 square roots this time. Always take what's in the denominator and multiply top and bottom by that. So it's gotta be square root of 7 over square root of 7. All right. Now, since these are both underneath square roots, I can multiply those together now. 2 times 7 is 14, and it's under a square root. Okay. On the bottom, square root of 7 times square root of 7 is square root of 49. And the last thing I can do then is take the square root of 49, and I get 7. Okay, and I got rid of the square root in the bottom, so I am good to go. There it is. That's how you rationalize the denominator. Let's look at number 3, because that's going to match up with number 3 in your homework on Schoology. And again, these problems are all just a little different. So if you're stuck on number 3, go ahead and refer to this problem to get you through. All right, so our focus point has got to be this. All right, since square root of 2 is on the bottom, that's what I am going to multiply top and bottom by. Square root of 2, square root of 2. Now, on the top, I can multiply the square root of 2 times the square root of 7 to get square root of 14, and I still have that 5 out in front, okay? And then on the bottom, square root of 2 times square root of 2, they're both underneath the square root, so I can go square root of 4. And let's see, on the top, I just get 5 square root 14. And on the bottom, we know the square root of 4 is 2. You should look for some other simplifying to do. I can't simplify 5 over 2 as a fraction. When I look at the square root of 14, you know how Mr. Webb taught you how to simplify radicals a couple days ago? There's no perfect square that goes into 14, so that's simplified as well. And most of your problems, there won't be much simplifying to do afterwards. Okay, just one, and that's going to be just like number 4 here, our last problem of the day. And this one can be kind of tricky. So a lot of you are going to get stuck on number 4 on your homework. You're going to want to look at this example to help you with it, okay? So I think you would know how to start it at this point. Square root of 2 in the bottom, so we got to multiply by square root of 2 over square root of 2. All right, and that's going to give me the square root of 12 on the top over the square root of 4 on the bottom. All right, so a lot of you might do this then, square root of 12, and then simplify square root of 4, you get 2. A lot of you might just put your answer like that, okay? Well, here's the problem. The square root of 12 can be simplified like we worked on a couple days ago. There is a perfect square that goes into 12. So I need to break up 12. Can anybody think of a perfect square that divides evenly in there? Yeah, it is 4. So I'm going to break up that 12 into square root of 4 times square root of 3. That's the same as square root of 12. Okay, and I still have that over 2. Okay. Well, the square root of 4 is 2. So I get 2 square root of 3 over 2. Then one more thing I can do, since there's a 2 on the top and a 2 on the bottom, those can cancel out. And I'm just going to get square root of 3 left on the top as my final answer. All right. So hopefully that was helpful for you when rationalizing the denominator. Um, if you have any questions, make sure you reach out to Mr. Webb or Miss Sievelton, because I think the Terminator is gone. I don't know where he went, but he gone. So anyway, summary. I'll have to take over for the Terminator. Summary is when rationalizing the denominator, multiply the numerator and denominator by the radical that's in the numerator. Okay, and that's how you rationalize the denominator. Best of luck.